gravity is not about particles accelerating, as one thinks about it in ordinary physics and Newtonian physics. In fact, what gravity is about is inertia. Inertial particles, when encountering a region where there is matter, and of course when we say encountering a region, obviously the effect of gravity goes off. In Newtonian physics, it's 1 over r squared, so it goes off forever, it just decreases. So it's really everywhere, but we'll say someplace where you wouldn't notice it, like distant intergalactic space. You can't even see any galaxies anywhere. As far as you know, you don't measure any gravitational effects, right? You have an inertial particle, you're satisfied that it's inertial, and it eventually you're riding along there, you're in this rocket with the rocket off, so you're inertial. And eventually, one day you wake up and you see your measurement instruments indicate that there's a galaxy up ahead. So you know something was moving. You were moving, they were moving, whatever. You got closer to each other. And now there will be gravitational effects. Or maybe the gravitational effects can come before you notice the distant galaxy in your instruments. It doesn't matter. But what will happen? You and everything inside your spacecraft will not change from being inertial. You're all still inertial. Just they experience a relative acceleration. What matter does, it has an effect on the medium, such that although inertial particles remain inertial, they experience a relative acceleration. So if you remember, we had, say, planet Earth over here, we had particles. If they dropping straight down to the Earth, of course, straight down to the Earth means straight down towards the center of the Earth, so they accelerate this way, exaggerating the angle, and there will therefore, in free fall, will be a relative acceleration between this way. If you drop them like this towards the Earth, obviously this one being closer to the Earth has a greater acceleration than this one, so there will be a relative acceleration between them, and that will be visible even in a free fall frame. So it's a real phenomenon, and the real phenomenon of gravity is the relative acceleration of inertial particles, where, again, since it's inertial particles, there is no way to distinguish an inertial particle in a gravitational field from one that's not in a gravitational field. It is inertial. The way to distinguish things is when you have neighboring inertial particles and you notice the relative acceleration.